Hello everybody. Today we are going to learn sets, which is a topic in discrete mathematics. And this comes to you by Star Academica. If you have any questions, suggestions, please email to this particular email account. We'll be very happy to answer and help you. Okay, so let's get started by the definition. What does a set mean? Okay, in real life situations, we always list things, list items that belong to a person, to something. For example, we list objects in a bag, in a shelf, in a pocket. So this is a practical way in real life. So how to represent these objects if we want to write them down and maybe manipulate in the future? Which is what we want to do in mathematics. Let's take a concrete example, which is, let us take John. He is a student in university and he's taking some classes this semester. Say he's taking mathematics, physics, biology, and English. On the other hand side, we have Alice, and she's also taking mathematics, literature and biology, and French. So there are plenty ways of listing these courses taken by these particular people. So one way, which is a very common way, is the following. So for John especially, let us list his classes: mathematics, physics, biology, and English. So to do it, we put braces, curly braces, left and right hand side, and we list the classes which are the members or the objects, and we put comma. We separate them by commas, as you see here. So this is called a set, and the mathematics, physics, biology, English, these objects that belong to this set are called the elements of the set. And what about Alice? For Alice also we do the same thing. She was taking actually mathematics, literature, and biology. We put curly braces, and in between them we put the names of the classes which are the elements of the sets: mathematics, literature, biology, and French. So between curly braces we list the objects separate them with a comma. So this is called listing, or the list method for the elements of a set. We already mentioned about it. Okay, an important question is, does the order matter if you are listing the elements inside the set? And the answer is no. For example, we have mathematics, physics, biology, and English as the members of the set. One could rewrite them, reorder them. For example, like physics, English, mathematics, biology, or English, physics, mathematics, biology. We have plenty ways of listing them. However, they are all the same because the order does not matter. So if somebody sees this writing or this one, whenever they have the same element, like mathematics is here, and English, it's in all parts. It's here, English is here and here. Biology exists in both, and they don't have anything more or less. They have the same objects, so they are the same sets. And what about sets? Is there anything particular? Can anything be a set? Well, the objects inside the sets must be well defined, okay? And the set must be well defined. Let's take an example. Suppose that somebody's talking about objects in a man's pocket living in New York. Here we have a problem because in New York there are millions of people, and there is an ambiguity which one we are talking about, which man it is, which one it is. So it's not clear. and this is not going to represent a set. So this is not a set. We have to be particular. Okay. Let's be more specific, and mathematically speaking, a set is an unordered collection of objects called elements or members of the set. So we go back to the John. The class is taking about John. Let us use J, which is going to be the case. The names for the sets are going to be used named by a capital letter like J or A or B. In this case, we prefer J. So J, curly braces in between mathematics, physics, biology, and English. Okay. A set is said to contain its elements, so the elements belong to the set. And we want to distinguish between the elements, which ones are in the set and which ones are not. For example, mathematics is an element of J, right? Mathematics is inside the set J, so we use this notation. We use this symbol. Please pay attention. So this means that mathematics is inside J, is an element of J, it belongs to J. So this is the symbol, like A. And if something is not in the set, it's not inside the set, or it's not an element of the set, we have a way to say it in mathematics, so we use this symbol. We cross, so we cross E. So for example, literature is not in J. Do we see literature in J? No. So literature is not in J. So literature is not an element of the set J. Okay, and it's a common thing that we name the sets with the capital J's, capital letters, and inside the sets usually we can have anything. Some in mathematics we mostly prefer to use small letters, but can be anything. Let's have some examples for listing methods. So the set of vowel letters in English, call the set capital V. They are A, E, I, O, and U. So this is the set of vowel letters in English. Let's have another example. The set of even positive integers less than equal to 8. 2, 4, 6, 8. It should be set of even, they are even. Positive, they are all positive. And less integers, positive integers, they are all integers and less than equal to 8. Okay, and what about another example? The set of odd positive integers less than 88. Again, positive integers, odd, so the smallest one positive odd is 1, the next is 3, 5, 7, goes up to 87 because they are supposed to be less than 88 or equal to 88 is an even number, so the largest one is 87. Here we have them. Okay, another example, we have a set A with symbols in it. We have plenty of different symbols. This can happen. So we have the number 5, we have the name Todd, we have the star symbol, we have a bullet as an element, we have a percentage, we have a little a, and we have here a symbol called symbol. This is something. We have a set braces, actually a set, and a B, capital B inside. So okay, everything is separated with the commas, as you see. So this thing is one element. Okay, so let's look at the examples. Todd is an element of A. Yes, it is. Great. Percentage is an element of A. Yes, it is. B is not element of A. Is this true? Yes, because we don't see B by itself. It's not there. However, we see B within the curly braces, with the curly braces as one single element, which is in between two commas. So this thing with the braces is an element of A. So this is a confusing, misleading. We have to be careful. Okay, again, the bullet itself is an element. Yes, it is. However, we don't see such a thing inside. So this is not element of A. See, we don't have anything with the curly braces here. It's just plainly bullet, simple. Okay, this all presentations here are examples of the list method, which are given as rosters. Okay, another way of representing the sets, it's called set builder, or a method where we use a property for the sets. So they are defined by a property, and this is useful when we have plenty of numbers around, plenty elements. There is no way to list them all. So here's an example: the set T of positive integers less than 100 that are multiples of 10 can be represented by the following notation. So we have T, again we open braces and close braces, curly braces, and we say X such that, so this reads, this symbol here, which is a line, you see, this will read this thing as such that. So it explains afterwards the property of this. So we have X such that X is a positive integer less than 100 that are multiples of 10. So inside this set we have positive integers less than 100 that are multiples of 10. So T is actually what? T is 10, 20, 30, 40 less than 100, so we have 90. All this is the whole set. We can list the elements because we have finitely many of them, quite. There are 9 items. But if this was to be 1000, okay, then there is no practical way of listing them out. So this writing or this representation of the set will be enough, and we don't have a way to list them. So that's why this is important, where we use such that symbol inside the set. We express the elements of the set. We express them by common property of the elements. Another way of writing it down, this set T, is this following. So we are supposed to get used to many ways of writing things down. So the elements are 10 times k, 10 times the multiples of 10 as was defined by the set T, and k is running from 1 to 9. So what happens if k is 1, we have 10 times 1, which is 10. If k is 2, we have 10 times 2, which is 20. If k is 9, we have 10 times 9, which is 90. So this is another way, another compact way of writing these elements. Okay, another example, say we have a set F of female students in John's class. So one way to write it down is the following. X is a student. First, X is a student in John's class such that X is a female. So this is again in between braces, curly braces. We have the general property of the elements of X, and we have a particular property for the elements of F. Okay, and how can we regard this definition? Here is a very, very general but concise. So we have an X within the set, or called superset, which contains everything. However, we restrict such that we use the symbol X with one or more special properties. If we go back to set F, pay attention please. So this is the class, the whole students are here. However, for this F, there is a restriction set such that the students are female. So this is what's happening. We'll see this in the future. Okay. Some special sets that we are going to run into in this course. So natural numbers start from 0 and we go with the counting numbers 1, 2, 3, 4, 5, 6. The set of natural numbers. The set of integers with a z. So we have positive integers, we have negative ones, and we have 0. So this is called also the whole number set. So another common name is the whole number set, or integers. And the set of positive integers, so we just put plus at the top of z, so we do not take the negative ones, and we can start from 0. So this positive integers becomes the same as natural number set. Okay, as we see, so z plus is equal to the natural number set. The set of rational integers, these are rational numbers. So we have P divided by Q type of numbers, where P and Q are both integers. However, we do not allow Q to be 0, so this has to be non-zero, otherwise it's not defined. So for example, 2 over 3 is a rational number. 4 over 1, which is 4, it's a rational number. So 4 over 1 is a rational number, at the same time it's an integer, right? So minus 5 over 2 is also a natural number. However, 5 over 0 is not a number. This is not defined. Okay, this is not allowed. Okay, what else? We have two more sets, important sets. Okay, the set of real numbers. What is that? This is the most complicated one, really. So all numbers that comes to your mind are in this site, which is called real numbers. For example, square root of 2. We'll see this in the future, that this cannot be written as a rational number. So there is no way to represent this as a fraction. So this is not possible. And pi is another one. It's an irrational number. It's not a rational number. And e, these are very particular. So r is larger than q, contains q inside. And the set of complex numbers, this is also not going to be really the main topic of this course, but let's have this thing inside our list. So these are the numbers of type a plus b times I, where a and b are real numbers, and I is a symbol whose square is equal to minus 1. Okay. Intervals, which are really important. You may remember them from calculus, right? Most of you have taken calculus. Okay. Okay, so we have closed interval. This is the presentation with the braces, closed brackets actually. We use these closed brackets. This is a very specific notation. So in between a and b, we have everything in between a and b, including the endpoints, left hand side, because we have equality here, and right hand side. If this is the real line, x, say, so we see a and b, and in between everything. Okay, so everything between a and b, including the endpoints a and b, because we have closed brackets. Open interval looks like this, with open brackets and anything in between a and b, but a and b are not included itself. And else, what else? We have the left open, so the left hand side is open, the right hand side is closed, closed this, open this. And what does it mean? A is not included in this set, b is included in this set, and anything in between. So this is the line, b is included, a is not included. We leave it as an open circle to emphasize, really. And another one, which is the last one regarding this, it's the right open, left closed. So the left hand side is closed, the right hand side is open. Closed means inside, b open means outside. It's not in the set, so this is how it looks like. Let's have some example. 2 is in between minus 1 and 3, so minus 1 closed, and 3 also closed, and 2 is somewhere here, right? Yes. So 2 is an element between minus 1, 3 closed. 2 is not element of 2, 3, so this is 2, and this is 3, say, and 2 is missing. In this set, 2 is not there, so 2 is not an element. 5 is not element between 0 and 4, so really, if this is 0 and this is 4, 5 is somewhere here. It's not inside the set. And the last example actually is 3 is not in minus 1, 3, so minus 1 closed, 3 open, right? 3 is not included in this set.